In the experiment of factors that influence the rise of flower dove, I'm Nadia from Group 4 will explain briefly the concept of this experiment, which is divided into two parts, starting from the rise of the dove up until strip plot design. As we all know, yeast plays a vital role in influencing the rise of flower dove as it serves as a leavening agent which causes the bread to expand by converting the fermentable sugars present in the dove into carbon dioxide and ethanol during fermentation. During fermentations, the carbon dioxide is produced and trapped as tiny pockets of air within the dove. The bubbles make the dove expand and rise. For our group, we decided to apply strip plot design into our experiment, which investigating the factors that influence the rise of flower dove. The basic split plot design involves assigning the levels of one factor to main plots arranged in a CRD, RCBD, or a Latin square, and then assigning the levels of a second factor to subplots within each main plot. In a strip plot design, the whole available area is divided into A horizontal strips and B vertical strips. One level of vector A is assigned to each row and one level of vector B is applied to each column. For example, if you had 3 multiplied 3 equals to 9 factors, the plot will have 9 sections as shown in the picture. The levels of first factor are randomized plot-wise, and the levels of second factor are randomized main plot-wise, and the levels of third factor are randomized. Each plot or replication is divided into number of vertical and horizontal strips depending on the levels of the respective factors. In this design, there are plot sizes. The first one is vertical strip plot for the first factor, which is known as vertical factor, and the second one is horizontal strip plot for the second factor, which is known as horizontal factor. And the final one is interaction plot for the interaction between two factors. You might wonder why we use split plot design as an experimental design. This is because several factors can be tested with increasing trends of precisions, and furthermore, this design is more efficient statistically with increased precision. 3 variables that are involved in this experiment are constant variable, independent variable, and dependent variable. Constant variable involves type of flower, type of yeast, water temperature, and the rise time. Meanwhile, for independent variable, the first one is amount of yeast and the second one is quantity of water are manipulated. Meanwhile, height of the dove rise is a dependent variable in this experiment. Materials that are used in this experiment are flour, yeast, and lastly water. Based on the figure, this is the procedure that we had done, and the crucial part in this procedure is in step 7, where we need to place each 9 containers randomly according to blocks. One is in the refrigerator, which is in the cold temperature, and another one is in the normal room temperature, and the last one is under the sunlight, which is in the high temperature. The table behind me shows the data of the dove height after leaving it for 4 hours according to blocks. And here we go, this is the final result of the dove rise, influenced by the amount of yeast and the quantity of water.
Hi, my name is Fatinaja and I will cover on measures of central tendency. So what are measures of central tendency? Measures of central tendency are summary statistics that represent the central point of typical value of dataset. Example of this measure include mean, median, and mode. Now let's continue with the calculation of mean and mode. To calculate mean, we need to refer the raw data that have been collected. Formula of mean is sum of terms divided by n, which is number of terms. For mean block 1 is 6.81 and block 2 is 7.53, and lastly for block 3 is 7.23. And alright, for calculation of mode, we just need to determine the value in the data set that occurs most frequently. Mode for block 1 is 8.50 and mode for block 2 is 8.0, and for block 2 there is no value that occurs frequently. Next calculation is median. Median for old data set is the easiest way to be calculated. Firstly, arrange the data value in ascending order and determine the value of the center at the center point. Median for block 1 is 7.0 and median for block 3 is 7.9, and lastly for block 3 is 7.1. For the last part, I will cover on variance and standard deviation. Variance is equal to average squared from the mean, while standard deviation is number square root. Variance for block 1 is 2.13 and standard deviation is 1.46. Variance for block 2 is 0.69 and standard deviation is 0.83. And lastly, for variance block 3 is 0.63 and standard deviation is 0.79. So that's all from me. Thank you.
And now, let's move on to hypothesis. The null hypothesis is all means are equal, and alternative hypothesis is at least one of the means is different from one of the other means. Now, I will explain about calculation for ANOVA table. The first part is for vertical strip analysis. This is the cross tabulation of block and amount of yeast. The value for grand total is 194.2. After that, we can calculate correction factor, which is 1396.801. By using correction factor value, we can calculate sum of square and block sum of square. We can also calculate the value for amount of yeast sum of square, block and amount of yeast, and error sum of square. The second part is for horizontal strip analysis. This is the cross tabulation of block and amount of water. For this part, we can obtain the value for block sum of square, amount of water sum of square, and block and amount of water. And the last one for this part is error sum of square. And the last part is for interaction strip analysis. This is cross tabulation of amount of yeast and amount of water. These are the calculations for sum of square of the interaction between amount of yeast and amount of water, and also error sum of square.
My name is Nur and Shafika. So now, let's proceed to the ANOVA table. So for this ANOVA table, after all the calculations has been made, we already got the sum of squares and the mean squares for 8 of the sources of variations in this strip plot design. So as we can see, we also got the F calculated value for factor A, which is amount of yeast. The value is 0.3, and for factor B, the amount of water, the value, the F calculated value is 0.52. And last one, the interaction between factor A and factor B, factor A amount of yeast and the factor B amount of water, the F calculated value is 4.2. So these F calculated values will be used to compare with the F table to determine whether there is a significant difference or not.
Next, we move to the part of correlation and regression. The correlation coefficient between amount of water and height of dough is 0.182, which is positive correlation. It indicates when the amount of water is increased, the height of dough is tend to increase. Then, the correlation coefficient between amount of yeast and height of dough is negative 0.089, which is negative correlation. It indicates that when amount of yeast is increased, the height of dough is also tend to decrease. So the regression between amount of water and height of dough, the p-value is less than the significance F value. It shows that non-zero correlation, so we reject the null hypothesis. And the regression between amount of yeast and height of dough, the p-value is also less than the significance F value. It shows the non-zero correlation, and we also reject the null hypothesis.
Moving on to the conclusion and decision for our experiment. From the ANOVA table that we have got from our data, the F calculation for the amount of yeast, which is factor A, is 0.30. The F calculation for the amount of water, which is factor B, is 0.52, and the F calculation for the interaction between factor A and B is 4.20. So for the amount of yeast, which is factor A, the F from the table at significance alpha 0.05 and 0.01 with degrees of freedom 2 and 4 are 6.94 and 18.00 respectively. So since the F calculation 0.30 are smaller than both F table, which is 6.94 and 18.00 at the 95 and 99% level of confidence, we fail to reject the null hypothesis, which is all treatment means are equal. Therefore, there is no significant difference. Meanwhile, for the amount of water, which is factor B, the F from the table at significance alpha 0.05 and 0.01 with degrees of freedom 2 and 4 are 6.94 and 18.00 respectively. So it is the same since the F calculation is 0.52 are smaller than both F table, which is 6.94 and 18.00 respectively. We fail to reject the null hypothesis, which is all treatment means are equal. Therefore, there is no significance difference. And lastly, for the interaction between amount of yeast and amount of water, the F from the table at significance alpha 0.05 with degrees of freedom 4 and 8 is 3.84. So since the F calculation 4.20 are larger than F from the table, which is 3.84 at the 95 and 99% level of confidence, we reject the null hypothesis, which is all treatment means are equal. And the last one is the F table at significance alpha 0.01 with degrees of freedom 4 and 8 is 7.01. So since the F calculation 4.20 are smaller than the F table, which is 7.01 at the 95 and 99% level of confidence, we fail to reject the null hypothesis, which is all treatment means are equal. Therefore, there is no significant difference.